Okay, so we're going to discuss the rational roots theorem. And so here we have, stop there. So here we have what a basic n equals 3 x cubed polynomial looks like, with 3 rational roots. It's the rational roots theorem, so we're not going to use complex roots. And yeah, and notice how we have r plus 1, r plus 2, r plus 3. That's basically because it's going to be root in factored form. It's going to be root times x, so it would be plus another root times x, so that'd be x squared, and this would be root times x, so you have one root, that x, two roots, that, and then the last one would be root times root. Note that here the a is in front, so at the end of the day, your y-intercept, what you're going to get, or when x equals 0, or just something to help you find the roots, because if you have this number right here, you will have this number right here, and you're just trying to find factors of that when put into your y equals x equation, those factors will be equal to 0, right? Because if it's an fx equation, I think we've talked about this a bunch. So if it's an fx equation and you have x minus 1, so obviously 1 would be 0, or x minus 1 is a factor, obviously 1 would be 0. So if you plug in 1 to your equation, it should work out. So we're trying to find some type of method where we can try and maybe fail, but still gather up all the possible roots, and then kind of plug them into this formula, check to see if they equal 0. And if they don't equal 0, kind of like say no, they don't work. And if they do equal 0, then we're going to save that as a root. So I'm just going to kind of explain really quickly. I think we've touched on this in class, but I'm just, for myself and for Mike, to make sure I understand it too, I'm just going to try to explain this. And so, yeah. So what's going to happen is this number is end up going to be, sorry, I'm not circling, this number is going to end up being a times r1 times r2 times r3, right? Because in factored form, you're going to have like a x blah blah blah, x blah blah blah, x, and then this times that, that's going to equal your y-intercept, and that's what's going to help you be able to factor into roots. So when we do these equations, we usually find that the a here is not always on the outside of the equation, as it is here. Or as in like ax cubed, blah, 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 blah. We usually find that it actually is within one factor, or, yeah, so we find that it's usually more like 2x minus 4. And then factored form, that's going to be, sorry, two x minus 4, and then factored form, that's going to be 2x minus 2, and then the 2 will just get thrown to the front. So you don't actually see that negative 2, yeah, so, yep. So what you're going to see in the y-intercept, or this number, is you're going to see that negative 4 times some other numbers. So what you want to do is you want to try to extract the 2, or the x minus 2. So to do that, there's like a couple things we have to do. And I think this goes over to the thing we were talking about in class, the P over Q. Or the Q might be like that, I'm not sure. And that just relates to, let me just give you a polynomial. I'll say 3x x here. Let me get a new page. Yeah. Okay, so that would be like, actually 2 works better. 2x cubed minus 5x minus x plus 6. Okay, it's fine. So you have this 2 number and you have this 6 number. And the p over q, I think, is the factors of 6 over yep. And so what that basically gives you is something like this, which would be 1, 2, and the idea here is that one of the roots, so you remember when I talked about the 2x minus 4 and how you're going to see that negative 4, or you're not going to see the negative 4, but the negative 4 is going to be there as one of the roots. It's actually going to be 2, because it's going to equal, and so right? So basically what this does is this kind of says, okay, so what are all the possible things that could have happened in one of these little monomials, I think, or linear formats? What could have happened in them? And for example, it could have been 1, and the 1 is just here because it's a factor of 2. It's just like saying that instead of 2x or 2x minus 4, it'd just be x minus 4. So we can just say that you can try all of these. So 1, 2, 3, and 6, and then those divided by 2, like here, like as if there was a 2 outside of them, where a root would actually be 2, and a root wouldn't be negative 4, as it would here. Yep. So, right. So what you can do is you can kind of check all of them, and that's what the formula would be doing. So it would be checking 1, 2, 3, 3 halves, 6, I think. Yeah. 1, 1 half. Forgot that one. And that would basically be saying, because it's a positive number, so it'd be putting these numbers into, I think, plus or minus these numbers into this formula. So, for example, let's just try 1, negative 1. Or sorry, let's try 1. So it'd be x plus 1. And so x negative 1. So let's try negative 1. So it would be 2 times just going to put plus 1. And that that's going to equal, so negative 1 cubed is going to be negative 1, so it's going to be negative 2 plus 5 plus 1 plus 6. And so that can't be a root, because that does not equal to 0. And so if I were doing my formula, I'd say equals no or something. And then I'd go into the next one. So I'd go on to, I mean, I guess we can try, no, let's just try 2. And just thinking, I'm just might think that, I don't think this is going to work, but maybe 3, see, because if you had 6 as a root, I'm pretty sure you'd have to have like a 1/2 as a root too, because if you had like 6 and 2 as a roots, but then you had the a, which is 2, right there. If you had that outside of like 6 and 2, I think it would be too big, yeah. Like the 6, it wouldn't equal 6. So I'm pretty sure if you had a 6, you'd have to have 1/2. And yeah. But anyways, let's just try to. Let's see what we can do until this equals. Here, let's go to a new page. So we had 2. Yeah. Okay, so let's try 2. So be 2 to the 4th power, which would be 16, minus 20, minus, so, be negative 4. Great, 2 works. Sweet. So you're going to have an x minus 2. And from there on, you can start, like, factoring out things. And remember we had the 1/2, 1, 2, 3 halves, 3 halves actually before 2, but sorry about that. And then we had 6. Yeah, so I thought 2, 3, and then 1/2. I'm thinking it might have been 2x minus 1. I mean, this is just a guess right now, and that'd be really cool if it's right, but I'm not sure if it is. X minus 2, then, oh, I think we might have to have a minus, so why don't we just have like 2x plus 1, x minus 2, x minus 3, there. And then that would just become, yeah, that'd just become, here, let's just try negative, or let's just try 3. So 3 times 3 times 3 would be 27. Oh, I'm not sure if it's 3. 27 times 2, which would be 54. So we have 54 minus 5, or minus 54. Is that true? Here, let's write this out. Yeah, I don't think this is going to work. No, it's 45, not 54. Okay, so this is going to be 54 minus 45 minus 3 plus 6. And that's going to equal 54 minus 45. That's going to be 9. Minus 3 is 6. Plus 6, so that's going to be 12. And that's not going to work. So my big theory went away. But that's okay. And, I mean, I could just go on and doing it. I don't know if that'd be smart. But I guess I can. Here, let's just see if we can find the polynomial. So let's try 3 halves now. Actually, this is going to be really long. But I'm going to try to make a formula for this. So, yes.